Hello students, today we come to chapter 1.4A. We are talking about the problems involving arithmetic sequences. And in this video, I will show you two examples. Let's go to the first one. There are 24 rows of seats in a concert hall with, that means 24 seats. When you look at this kind of questions, you may highlight the important information. And 16 seats in the first row, and each succeeding row has 3 seats more than its preceding row. So let's do some understanding. We draw some graph first. For the first row, we have 16 seats, right? And then for the second row, how many? Now here it states 3 seats more than its preceding row. So the first is 16, then the second will be 16 plus 3, right? So you will get 19. And then we move on. In total, there are 24 rows, right? So now, first of all, we need to find the number of seats in the first and in the last row. Then first of all, this is the first, the T1, and this is the T2, and this is the Tn. So we can let Tn be the number of seats in the, because this is n, then we let it is in the nth row. So now, what is the first term? The first term means T1, right? So A is equals to T1. So T1 then will be 16, right? So A is 16, T1. And what is D? D then, you can use the second term minus the first term, or you can just, the information is given by the questions is 3 seats more, right? So you will get D is 3 directly. Then now we need to find the last row, and there are total 24 rows. So it means we are going to find T24. Then we use the formula we learned before. Let's try to remind you what is the formula. So Tn equals to A plus n minus 1d, right? Then T24 will be A plus n minus 1d, which is 85. And finally, we give the conclusions. There are 85 seats. Remember to write this sentence, otherwise you may lose some marks. According to the missing of this. And now we go to part B. So which row has 58 seats? So we just set the kth row. B 58 seats, and then we find a k, right? So we can let Tk equals to 58. And then we use the formula again. So A plus n minus 1 d equals to 58. So we get 3 times k minus 1 is 42. Then we get k is 15. 42 over 3, 14, and then you plus 1. So again, we give the conclusion. So the 15th row has 58 seats. So this is the solutions of the first example. And then we'll come to the second one. Now this is more complicated when you look at the questions. So, but actually, if you understand the wordings and the concept behind, they are similar. Now in the figure A, B1, C1, D1, it means first, this is the first triangle. And then with 3 cm, it's already shown in the figure. And more squares are drawn with sides following the pattern below. The length of the side of square A, B2, C2, D2. This means this one, the second one. okay, is longer than that of the square of the first one, right, by d. So you see here, this is original, we have 3, right, and then now it's at d cm, and then we draw or we construct the second triangle. Okay, and then we just, okay, so far so on, and then we add d again, we get the third triangle here, right? So we just move on, okay, and then, okay, this is the situation. So now it is given that the length of the side of square a b5 c5 d5 is 11 cm. So now, okay, actually we're concerning the length of the side. Okay, this is very important. So you need to know what you are actually is your concern. So now, okay, maybe first of all, okay, again we can let Tn, like the previous example, let Tn be the length of the side of square. We just simply look at the format. This is A, B1, C1, D1, right? This is A, B2, C2, D2, and this is A, B5, C5, D5, right? So you just replace the 1, 2, 5 by n, right? So it will be A, Bn, Cn, Dn. So it means T1 will be the length of the side of square A, B1, C1, D1, which is the first term. And then T2 will be the second term, like that. So now we get A equals to T1, which is 3 cm, right, given. And what is D? Actually, we are going to find, right? But in order to find D, we get this information. So we get T5 is 11, right? So we can use the formula again. I just write once again here. So Tn equals to A plus n minus 1d. Okay, so T5 is 3 plus n minus 1d, and then we get 4d is 8. So this 2, okay, we get this directly. Now, Ronald has a piece of A3 paper of the side given. He claims that he can draw 20 squares according to the above pattern. Do you agree? Then let's see whether we can have the 20. So we just let K, okay, like be the number of triangle we can draw, right? So if we consider let K squares can be drawn. Then now, because we are drawing the square, right? So we need to consider these two lengths, right? You just imagine if you have an A3 paper, and this is 297 mm, and this is 420 mm. Then when you draw the triangle, okay, like this. First, okay, you will be end. This is shorter because, right? So actually, when we draw the triangle, we need to consider this length, okay, rather than this. So if K triangle can be drawn, then the length of the side of the triangle A, B, K, C, K, D, K must be smaller than this one. Okay, must be smaller than this one. Okay. So we let TK is smaller than or equal. Okay, it can be actually it cannot be equal, because if it is equal, then you cannot draw and the like right at the side. So we just simply you should use smaller than instead. Smaller than 29.7, because we are looking at cm here. We are looking at cm, but this is given is mm. Okay, so 29.7 cm. Okay, so now we change to an inequality. Then we make use of the formula. A is actually 3. So sorry, write A again. So A plus n minus 1 d, and then it's smaller than this one. Okay, so we get 2 k minus 1 smaller than 32.7, and then you get k minus 1 16.35, right? 16.35. And then so you get, sorry, I make a mistake here. It should be 26.7, and this is 13.7, 13.35. And then finally we get 14.35. Okay, so what is the meaning of k smaller than 14.35? It means at most you can draw 14 triangle by this A3 paper, right? So what is the claim? You can draw 20. You draw 20, right? So is it correct? Then obvious it is no, right? So you just simply give the conclusion. So Ronald's claim is not correct, as at most 14 squares can be drawn. Okay, so these are the 2 examples I would like to show you. Then you now go to do the quick practice 1.21 and 1.22. I will show you the solutions in another video.